Hello students, hope you are doing well. In this video we are going to discuss designing an IP address plan of Unit 5, designing IP addressing in the network and selecting routing protocol for the subject enterprise network design of B7 semester IT, University of Mumbai. In this lecture we are going to cover designing an IP address plan. So there are several things like private and public IP version 4 addresses, determining the size of network, planning the IP addressing hierarchy, method of assigning IP addresses and name resolution, and finally DHCP and DNS server location in a network. So these are the topics which we will cover in this lecture. As we know that the IP address space is divided into public and private space. Private addresses are reserved IP addresses that are to be used only internally within a company's network, not on the internet. Private addresses must therefore be mapped into companies' external registered addresses where sending anything on the internet. Public IP addresses are provided by external communication. In this figure, here you can see that different type of addresses. Okay, like private address and public address. So different type of addresses are there. RFC 1918 address allocation for private internet defines the private addresses like 10.0.0.02, 10.255.255.255, then 172.16.0.02, 172.31.255.255, and 192.168.0.0 to 192.168.255.255. So these are the addresses, private IP addresses, and the remaining addresses are public addresses. Okay, so what is the difference between private addresses and public addresses? So there are some selection criteria, private versus public address selection criteria. The very few public IP addresses are currently available. As we know that all the addresses are allocated to different sites. So internet service providers can assign only a subset of class C addresses to their customers. Therefore, in most cases, the number of public IP addresses assigned to organization is inadequate for addressing their entire network because it is 32-bit in size. Okay, if we calculate, so there are 2 to the power 32 addresses possible if we are not considering class A, class B, class C, class D and class E addresses. So this is just 4 giga addresses, 4 giga or 4 into 2 to the power 30 addresses are available. Okay, and the devices, number of devices, computers, mobile phone, these are very high with respect to this number. This number is not sufficient. 4 giga is very smaller number as compared to the devices available nowadays. Okay, so ISP assign only a subset of class C addresses to their customer. Therefore, in most cases, the number of public IP addresses assigned to organization is inadequate for addressing their entire network. The solution to this problem is to use private IP addresses within the network and translate these private addresses to public addresses when internet connectivity is required. When selecting addresses, the network designer should consider these questions. First thing is, are private, public, or both IP address type is required? Second question, how many AND system need only access to public network? This is the number of AND system that needs a limited set of external services such as email, file transfer, or web browsing, but do not need unrestricted external access. These AND system do not have to be visible to the public network. Then third question arises, how many AND system must have access to and be visible to the public network? This is the number of internet connection and various servers that must be visible to public networks, such as public servers and servers used for e-commerce, such as web servers, database servers, and application servers, and defines the number of required public IP addresses. These AND systems require globally unambiguous IP addresses. And fourth question, where will the boundaries between private and public addresses be, and how will they be implemented? Now come to next topic, interconnecting private and public addresses. According to its needs, an organization can use both public and private addresses. A router or firewall acts as the interface between the network's private and public selection. When public addresses are used for addressing in the network, this network must be connected to internet. Network address translation, that is NAT, network address translation, okay, or port address translation, or port address translation must be used to translate from public to private to public addresses and vice versa. NAT or PAT is required if accessibility to the public internet or public visibility is required. Static NAT is one-to-one mapping of unregistered IP addresses to registered IP addresses, and dynamic NAT maps unregistered IP addresses to registered IP address from group of registered IP addresses. NAT overloading or PAT is the form of dynamic NAT that maps multiple unregistered IP addresses to single registered IP address by using different port numbers. In this figure, we can see that many to one, one to one, and no translation required networks are available. Here, private network is available, private access to public network, private public visibility needed, and in this case, public network. So, the NAT or PAT can be used to translate any of the following, like one private address to one public address, many private address to one public address, or combination of these. In case of one private address to one public address, use in case when servers on external network with private IP address must be visible from public network. The translation from the server's private IP address to public IP address is defined statically. Now, many private addresses to one public address. This is the second. Okay. In previous case, static address is there. Static address is there. Now, many private addresses to one public address. It is used for AND system that require access to the public network but do not have to be visible to the outside world. And third is the combination of both. It is common to see a combination of previous two techniques deployed throughout the network. So this is very, very common. Guidelines for the use of private and public addresses in the enterprise network. In this figure, the typical enterprise network uses both private and public IP addresses. Private addresses are used throughout the enterprise campus, enterprise branch, and enterprise teleworker module. Enterprise campus, enterprise branch, and enterprise teleworker module. Here we use the private addresses. Okay, so this shows private address. It is also private address, and it is also private address. Enterprise branch also uses private address. So this is the scenario, and there are different modules. These modules include public addresses like internet connectivity module. This is the internet connectivity module where public IP addresses are used for the internet connections and publicly accessible servers. Then come to e-commerce module. This is the e-commerce module. It is available publicly, where public IP addresses are used for database, application, and web servers. Then the remote access and virtual private network. So this is remote access and virtual private network. The enterprise data center module and the WAN and metropolitan area network. WAN and metropolitan and this enterprise data center module and site-to-site VPN module. So there is site-to-site VPN module also. This where public addresses are used for certain connection. Public addresses are used for certain connection. Okay. Let us determine the size of network. The first step in designing an IP addressing plan is to determine the size of network to establish how many IP subnets and how many IP addresses are needed on each subnet. To gather this information, we need to answer some questions like how many locations does the network consist of? The designer must determine the number of and type of locations. Second question, how many devices in each location need addresses? The network designer must determine the number of devices that need to be addressed, including the AND system, router interfaces, switches, firewall interfaces, and any other devices. Third question, what are the IP addressing requirement for individual location? So the network designer must determine and collect information about which system will use dynamic addressing and which will use static addressing, and which system can use private instead of public addresses. Then last question, we need to find what subset size is appropriate. Based on the collected information about the network, number of network and plan switch deployment, the designer estimates the appropriate subnet size. For example, deploying 48 port switches would mean that subnet with 64 host addresses would be appropriate, assuming one device per port. Now come to determining the network topology. Initially, the designer should acquire a general picture of network topology. This will help determining and correct information to gather about network size and its relation to the IP addressing plan. With this general network topology information, the designer determined the number of location type, and their correct correlation. Like in this figure, we can see that main office is located in San Francisco. Regional or international offices is located at Denver and Houston, and remote offices are located at some remote places. So here we need to see that how do we use these things. Okay, now come to size of individual location. For this network location information for the topology, okay, suppose this is the topology. So how do we determine that network topology? Suppose location is San Francisco, okay, and the type of this location is main office, and we need to add comment like the central location where majority of users are located. So this is the table which determines or which give information for the topology. Okay, similarly for this Denver region, we need to write location as Denver and type is regional or international office and put the comment connects to San Francisco main office. Okay, connect to San Francisco main office. Clear? San Francisco main office. Similarly, for Houston, it is also connected to San Francisco and it is also regional office. Similarly, for remote offices shown here, remote office 1, remote office 2, and remote office 3. So remote office 1 and 2 is connected to Denver regional or international office, while remote location remote office 3 is connected to Houston. Okay, so this information we need to put here. Size of individual location. The network size in terms of IP addressing plan relates to the number of devices and interfaces that need an IP address to establish overall network size in simplistic way. The designer determines the approximate number of workstation servers, Cisco IP phones, router interfaces, switch management and layer 3 interfaces, firewall interfaces and other network devices at each location. This estimate provides the minimum overall number of IP addresses that are needed for the network. In this figure, if we incorporate this figure into table, so this table is drawn for San Francisco office. Its office type is main. Total number of workstation required 600. Servers are 35. IP phones are 600. Router interfaces are 17. Switches are 26. Firewall and other devices interfaces 12, and reserve is 20%. So total 1290 individual locations or 1290 size is coming. Okay. Some additional addresses should be reserved to allow for seamless potential network growth. The commonly suggested reserve is 20% for main and regional offices and 10% for the remote offices. However, this can vary from case to case. The designer should carefully discuss future network growth with organization representative to obtain a more precise estimate of the required resources. So this is how we can calculate. Like in case of Denver, it is regional office, total 210 workstations, 7 servers, 210 IP phones and 10 router interface, 4 switches, firewall and other device interfaces are not there. Reserve locations or reserve IP reserve addresses are 20% and total number is 441. For one remote office number 2, it is total 35. So this is how we can calculate total number of addresses. So this is coming for this particular topology, this is coming 2144. Planning the IP addressing hierarchy. The IP addressing hierarchy influences network routing. So here we will describe IP addressing hierarchy and how it reduces routing overhead. Here also discuss the issue that influence the IP addressing plan and routing protocol choices, including summarization, fixed length subnet masking, variable length subnet masking, and classful and classless routing protocol. So hierarchical addressing. First thing is hierarchical addressing. The telephone numbering system is hierarchical system. For example, this is the telephone number. Starts with +91. +91 is the country code for India. 22 is STD code for Mumbai. And 2654 is the local exchange code. And 3300 is the Mumbai University's number. So this is the number and this is the hierarchy system followed for telephone numbering. Likewise, Indian postal code. Suppose the postal code is 400098. So how do we identify what is the meaning of this postal code? 4 shows West Zone. Okay. Then state Maharashtra. This is coming under Maharashtra state because the pin code consists of 0 to 4. So this consists of 0 and from 0 to 4, second digit 0 to 4 is Maharashtra. Then sorting district. Sorting district is Mumbai. 0 is code for Mumbai. Then 098 is the post office name. What is the name of post office? Kalina Market. Okay. So this Mumbai University's post office is at Kalina Market. The telephone architecture has handled prefix routing or routing based only on the prefix part of the address for many years. Like a telephone switch in Detroit, Michigan does not have to know how to reach a specific line in Portland, Oregon. It must simply recognize that call is not local. A long distance carrier must recognize that area code 503 is for Oregon, but it does not have to know the details of how to reach the specific line in Oregon. The IP addressing scheme is also hierarchical, and prefix routing is not new in IP environment. As in the telephone example, IP routers make hierarchical decisions. Recall that an IP addresses comprise a prefix part and host part. A router has to know only how to reach the next hop. It does not have to know the detail of how to reach an end node that is not local. Routers use the prefix to determine the path for destination address that is not local. The host part is to reach local host. So in this IP address, we can see this is just sample. These are the actual example. This is just sample example because I don't know what is the IP address of Mumbai University. So suppose IP address of Mumbai University starts with 128.78. So this shows the University of Mumbai. Then dot 42, it shows School of Computer Science and IT. And 6 is the system number. So this is how hierarchical IP addresses are used in daily life. Now come to root summarization. With root summarization, it is also referred to as root aggregation or supernetting. Okay, this is also known as supernetting, subnetting and supernetting. One route in the routing table represent many other routers. Summarizing routes reduces the routing update traffic. It is very clear. If we know only one, means how many routes are there. If we know only one router, accessible router, then we need not to maintain all these addresses. Okay. Summarizing routes reduces the routing update, which can be important on low speed links and reduces the number of routes in the routing table. Overall router overhead in the router receiving the routes. In a hierarchical network design, effective use of route summarization can limit the impact of topology changes in the router in one section of the network. If the network had not adopted route summarization by standardizing or classless interdomain routing, it would not have survived. Okay, so this is just one example of route summarization or also known as supernetting. For summarization to work correctly, there are some requirements. First thing is multicast IP addresses must share the same leftmost bit. Routers must base their routing decision on 32-bit IP addresses and prefix length of up to 32-bit. Then routing protocol must carry the prefix length with 32-bit IP addresses. For example, assume that router has these network behind it 192.168.168.0 24-bit of subnetting we are going to do or subnet mask is there. So if we write this 192.168.168.0, this looks like this. Okay. And similarly for all other networks with 24-bit subnet mask, there are these many bits common. Number of common bits are 21. Number of non-common network bits are 3. These are network bits. Actually, we have make 24-bit subnet mask, but only 21 bits are common and number of host bits are 8. So these are the host bit. Okay. Each of these network could be advertised separately. However, this would mean advertising 8 routes. Instead of this, router can summarize the 8 routes into one route and advertise 192.168.168.0. Okay, 192.168.168.0 slash 21, because we have grouped all the network. By advertising this one route, the router is saying route packet is to me if the destination has first 21 bit the same as the first 21 bit of 192.168.168.0. So here we can understand how do we summarize the route. Now let us discuss the concept of CIDR. What is CIDR? CIDR is a mechanism developed to help alleviate the problem of IP address exhaustion and growth of routing table. The idea behind CIDR is that block of multiple addresses, for example, block of class C addresses, can be combined or aggregated to create larger, that is more hosts allowed, classless set of IP addresses. You are having idea of classful IP addresses and classless IP addresses. No classes are there in case of classful. A, B, C, D, and E classes are there. Based on prefix bits, we decide which class it belongs to. Not only the classes, also subnet mask. Masking is also important, whether it is 8-bit, 16-bit, or 24-bit subnet mask. Based on this, we are able to say that which class it belongs to. And these bits are strict. But when we are talking about CIDR, it is not very strict. Okay. So, for example, blocks of class C addresses can be combined or aggregated to create a larger, that is more bits is allowed, classless set of IP addresses. Blocks of class C network numbers are allocated to each network service provider. Organizations using the network service provider for internet connectivity are allocated subset of service providers address space as required. These multiple class C addresses can then be summarized in routing tables, resulting in fewer route advertisement. And one important thing we need to note that CIDR mechanism can be applied to block of class A, B, C addresses. It is not restricted to class C only. CIDR is described in RFC 1519. RFC 1519, classless interdomain routing and address assignment and aggregation strategy. IP addressing hierarchy criteria. IP addressing hierarchy has important impact on the routing protocol choices and vice versa. The decision about how to implement the IP addressing hierarchy is usually based on some questions. First question is hierarchy needed within the IP addressing plan? What are the criteria for dividing the network into route summarization group? How is route summarization performed and what is the correlation with routing? Is a hierarchy of route summarization groups required? And how many end system does each route summarization group or subgroup contain? So there are certain benefits of hierarchical addressing. A network designer decides how to implement the IP addressing hierarchy based on network size, geography, and topology. In large network hierarchy, within the IP addressing plan is mandatory for a stable network, including a stable routing table. For there are some reasons like a planned hierarchical IP addressing structure with room for growth is recommended for the network of all size. So first thing is influence on IP addressing on routing. An IP addressing plan influence the network's overall routing before allocating blocks of IP addresses to various parts of the network and assigning IP addresses to devices. Consider the criteria for appropriate and effective IP addressing scheme. Routing stability, service availability, network scalability, and modularity are some crucial and preferred network characteristics and are directly affected by IP address allocation and deployment. Then, modular design and scalable solution. Whether building a new network or adding a new service on top of existing infrastructure, modular design helps to deliver a long-term scalable solution. IP addressing modularity allows the aggregation of routing information on a hierarchical basis. Then, route aggregation. Route aggregation is used to reduce routing overhead and improve routing stability and scalability. Okay, stability and scalability. However, to implement route aggregation, a designer must be able to divide a network into contiguous IP address areas and must have solid understanding of IP address assignment, route aggregation, and hierarchical routing. Now come to summarization group. To reduce routing overhead in a network, in a large network, a multi-level hierarchy might be required. The depth of hierarchy depends on the network size. Okay, so this is just example. And the size of highest level of summarization. This figure shows an example of network hierarchy. Building 1, building 2, it is aggregated. Building 1, section 1, section 2 is aggregated, then it is aggregated with building 1, and this 2 aggregation is on the top. So let us discuss different level. First level, that is summarization group. Network location typically represent the first level of hierarchy in enterprise network. Each location typically represent a group of summarized subnet known as summarization group. Come to second level. A second level of hierarchy can be done within first level summarization group. For example, large location can be divided into smaller summarization group that represent the building or cities within the location. Not all first level summarization group require a second level of hierarchy. And finally, third level of hierarchy. Here you can see the section inside building. To further minimize potential routing overhead and instability, a third level of hierarchy can exist within the second level of summarization group. For example, sections or floors within individual building can represent the third level of summarization group. Impact of poorly designed IP addressing. A poorly designed IP addressing scheme usually results in IP addresses that are randomly assigned on an as-needed basis. In this case, the IP addresses are most likely dispersed through the network with no thought as to whether they can be grouped or summarized. A poor design provides no opportunity for dividing the network into contiguous address areas and therefore no means of Implementing route summarization. This figure shows a sample network with poorly designed IP addressing. It uses dynamic routing protocol. Suppose that a link in the network is flapping, means changing its state from up to down and vice versa 10 times per minute. Because dynamic routing is used, the router that detect the change send routing updates to their neighbors. Those neighbors send to their neighbors and so on. Because aggregation is not possible, the routing update is prolonged throughout the entire network, even if there is no need for distant router to have detailed knowledge of the link. The impact of poorly designed IP addresses includes excess routing traffic consumes bandwidth. When any route change, router sends routing update. Without summarization, more updates are sent and the routing traffic consumes more bandwidth. Simple. Then increase routing table recalculation. Processing overhead. Okay. Routing update require routing table recalculation with effect of router's performance and ability to forward traffic. Third is possibility of routing loops. So this is the routing. When too many routing changes prevent routers from converging with their neighbors, routing loops might occur, which might have a global consequences for an organization. So be careful, avoid such type of loops. Okay. Benefits of route aggregation. Implementation or implementing a route aggregation on border routers between contiguously addressed areas control routing table size. In this figure, we can see an example of implementing route summarization or aggregation on area borders in a sample network. If a link within one area fails, routing updates are not propagated to the rest of the network because only the summarized route is sent to the rest of the network and it is not changed. The route information about the failed links stays within the area. This reduces bandwidth consumption related to routing overhead and relieves routers from unnecessary routing table recalculation. So here you can see that different areas divided and this is the summarization point, and at this summarization point only summarize route 10.1.0 is propagated to the rest of the network. So this is the example of or benefit of route aggregation. Fixed and variable length subnet mask. Another consideration when designing IP address hierarchy is the subnet mask to use either the same mask for entire major network or different mask for different parts of the major network. A major network is a class A, B or C network. Fixed length subnet masking is when all subnet mask is in a major network must be same. Okay. And variable length subnet mask is when subnet mask within the major network can be different. In modern network, VLSM should be used to conserve IP addresses. FLSM requires that all subnet of major network have the same subnet mask, which therefore result in less efficient address space allocation. Like in the top network, you can see the network 172.16.0.0/24 or slash 16 is subnetted using FLSM. Each subnet is given a 24 slash 24 mask. Actually, it is 172.16.0.0/16. Okay. and this is given this mask. The network is composed of multiple LANs that are connected by point-to-point WAN link. Because FLSM is used, all subnet have the same subnet mask. This is inefficient because even though only two addresses are needed on the point-to-point link, a /24 subnet mask with 254 available host addresses used. VLSM, on the other side, makes it possible to subnet with different subnet masks and therefore result in more efficient address space allocation. VLSM also provides a greater capability to perform route summarization because it allows more hierarchical level within the addressing plan. VLSM requires prefix length information to be explicitly sent with each address advertised in a routing update. Like in the lower network shown in this figure, this has same subnet, okay, same mean 172.16.0, 172.16.0.0/16 is subnetted using VLSM. The network is composed of multiple LANs that are connected to point-to-point WAN links. The point-to-point link have a subnet mask of /30. Point-to-point link have the subnet mask of /30, providing only two available host addressing, which is all that is needed on this particular link. The LAN have a subnet mask of 24 because they have more hosts that require address. Okay, for consideration. To use VLSM, the routing protocol in use must be classless. Classful routing protocol permits only FLSM. What is VLSM and FLSM? Already discussed. Fixed length and variable length subnet mask. Okay. So with classful routing, routing update do not carry subnet mask. With classful, it does not carry subnet mask. But classless routing protocol carries the subnet mask because it in classful. Why it is required? It is not required because if we know that it is class 1 class A address, then what will be the subnet mask? Class B, for class B, how many bits are allocated? Likewise. So classful routing protocol. Let us discuss classful routing protocol in this figure. Okay, there are some rules which we need to apply when classful routing protocols are used. The routing update do not include subnet mask. First thing, routing update do not include subnet mask. Second thing is, when routing update is received and routing information is about one of the following. Like first thing is, routes within the same major network is configured on receiving interface. The subnet mask configured on the receiving interface is assumed to apply to receive routes also. Therefore, the mask must be same for all subnet of a major network. In other words, subnetting mask must be done with FLSM. Second thing is, routes in different major network that configured on receiving interface, the default major network mask is assumed to apply to the receiver route. Therefore, automatic route summarization is performed across the major network like class A, class B or class C boundaries, and subnetted network must be continuous. This figure shows, what is this figure shows here? In this figure, a simple network with discontiguous 172 in this figure, not in this figure. 172.16.1.24 or 00 network that runs a classful routing protocol. Router A and C automatically, this router A and C automatically, what it is doing? Automatically summarize across the major network boundary. So both send routing information about 172.16.0.0 rather than individual subnet, like what is the individual subnet? 172.16.1.0/24 and 172.16.2.0/24. Consequently, router B receives two entries for the major network 172.16.0.0 and it put both entries into routing table. Okay. Router B therefore might make incorrect routing decision. Because of these constraints, classful routing is not often used in modern network. Routing Information Protocol version 1 is an example of classful routing protocol. Okay, RIP version 1. Now come to classless routing protocol. So this is classless. In this case, here it is also classless. So if we illustrate this, so based on this diagram, we can derive the classless diagram, and this is classful diagram. The routing update includes subnet mask. First thing, it includes subnet mask. Then VLSM is supported. Obviously, variable length subnet mask is supported. Here FLSM, fixed length subnet mask, is used. Fine. Automatic route summarization at the major network boundary is not required, and route summarization can be manually configured. So scheduled network can be discontiguous, not scheduled or subnetted. Subnetted network can be discontiguous. Subnetted network, all these subnetted network can be discontiguous. Okay. So in this figure, how discontiguous networks are handled by classless routing protocol. This figure shows the same network as in this figure. This is the same network, but running a classless routing protocol that does not automatically summarize the network boundary. In this example, router B learns about both subnetwork like this and this, both the subnetwork, one for each interface. Routing is performed correctly. Although using discontiguous subnet with classless routing protocol does not pose the routing issue as demonstrated in previous case, contiguous blocks of IP address IP network should be used whenever possible to promote more efficient summarization. Okay. Hierarchical IP addressing and summarization plan. So in this example, we have already know that the number of available host addresses on subnet is calculated by formula. What is the formula? 2 to the power h minus 2, where h is the number of host bit, number of host bits, and the number of bits set to 0 in subnet mask. Okay, so these two are reserved because of subnet and supernetting. The first two columns in this table show the location and number of IP addresses required at each location for sample network. shown in this figure. Okay, for this particular figure, we draw the address block by location. Now, the third column here is rounded power of 2. Okay, rounded power of 2. Actual required is this and the rounded power of this. Suppose and number of host bits are 11. If we calculate 2 to the power 11, it will give 2048. 2 to the power 10 will give you 1024. Likewise, address blocks are assigned like this. Okay, so how do we assign the address block? There are one more thing. This particular value, number of bit value, is used to calculate the required number of host bit. Okay, assume that class B address 172.16.0.0/16 is used to address this network. The fifth column is a straight sample address block allocated to each location. So this is shown here for location San Francisco. This is the address for remote office 3. These are the addresses. So we know that how, because if we consider 17 number of system. Okay, so how many bits are required to address 17? These are 5 bits. 1 2 3 4 5 and 1 2 3 4 5 5 bits. Okay, 0 1 2 3 4. If we calculate the maximum number of system, then this is 2 to the power 5. That will give you 32 systems including 0 and 31. Fine. So this is how calculated the rounded power of 2. Means the extensibility is up to 64 system and so on. Here the example is shown as 21. 21 has 64 different because it is considered 21 can be represented by 5 bit also. So this might be 32, not 64, but because of extensibility number of host bit we have chosen 6 instead of 5, therefore it is coming 64. Okay, now come to here also the IP address summarization is given. By this diagram we can very easily understand that how do we use hierarchical IP addressing plan. Methods of assigning IP addresses. Before selecting the desired IP address assignment method, there are some questions which we need to answer. First is how many devices need an IP address? Which device requires static IP address assignment? Is IP address renumbering expected in future? Is the administrator required to track devices and their IP addresses? Do additional parameters like default gateway name server and so forth have to be configured? Are there any availability issue? Are there any security issue? So these are the questions. On the basis of these questions, we can assign the IP addresses by any of the one method, static and dynamic. An IP address is statically assigned to a system. The network administrator configures the IP address default gateway and name servers manually by entering them into a specific file or files in the end system with either a graphical or text interface. Static IP address assignment is an extra burden for administrator, especially on large scale network who must configure the addresses on every end of the system in the network. When we consider security issue, we assign the addresses statically. Means we need to configure either we need to type the ifconfig command, ifconfig, and some other commands are there. Okay, so it will automatically show the IP address or whatever types of there, or we need to go manually on the interface and right click on this. It will automatically show the property. Here in property, we need to enter the IP address. Okay. Then domain name and default gateway and subnet mask. These all information we need to fill manually. And when we enter static IP address, we are having idea about how many addresses we are using and from which place to which place these addresses are available. And on the basis of these, we can allow or we can use firewall to block some other users. Another is dynamic. It mostly uses DSCP protocol, dynamic host configuration protocol. IP addresses are dynamically assigned to end system. Dynamic address assignment relieves the administrator or manually assign an address to every network device. Instead, the administrator must set up server to assign the addresses on the server. The administrator define the address port and additional parameter that should send to the host. Default gateway name servers, time servers, and so forth. On the host, the administrator enables the host to acquire the address dynamically. This is often the default. When IP address reconfiguration is needed, the administrator reconfigure the server. When then perform the host renumbering task. Examples of available address assignment protocol includes Reserve Address Resolution Protocol, that is RARP, okay, and DSCP. DSCP is the newest and provide the most features. So we use DSCP, that is Dynamic Host Configuration Protocol. To use static or dynamic address assignment. To select either a static or dynamic end system IP address assignment method or a combination of the two, consider first thing the node type. Network devices such as router and switches typically have a static address. End user devices such as PCs typically have dynamic addresses. The number of end system. If there are more than 30 end system, dynamic address assignment is preferred. Static assignment can be used for a smaller network. Clear? Renumbering. If the renumbering is likely to happen, there are many end system. Dynamic address assignment is the best choice. With DSCP, only DSCP server reconfiguration is needed. With a static assignment, all the hosts must be reconfigured. Address tracking. If the network policy requires address tracking, the static address assignment method might be easier to implement than the dynamic address assignment method. However, address tracking is also possible with dynamic address assignment with additional DSCP server configuration. See, sometimes what happens, we need to deploy our server for practical purposes. I'm not discussing about enterprise. I'm just discussing about when we need to use some IP addresses for programs like MPI programming. MPI is message passing interface programming. So here we need to use static IP address so that we may be able to send or we may be able to receive the data from fixed system to fixed system. But in other cases, most of the time dynamic configuration is required, and dynamic configuration provides greater flexibility. Then additional parameters. DSCP is easiest solution when additional parameters must be configured. The parameter have to be entered only on the DSCP server, which then sends the address and those parameters to the client. High availability. Statically assigned IP addresses are always available. Dynamically assigned IP addresses must be acquired from server. If the server fails, the addresses cannot be acquired. To ensure reliability, a redundant DSCP server is required. Then last is security. With dynamic IP address assignment, anyone who connects to the network can acquire a valid IP address in most cases. This might be a security risk. Static IP address assignment poses only minor security risk, as already discussed. Guidelines for assigning IP addresses in enterprise network. The typical enterprise network uses both static and dynamic address assignment method. In this figure, the static IP address assignment method is typically used for campus network infrastructure devices. Okay, and in server form and enterprise data center modules. So where we use the static IP address, static at enterprise campus network infrastructure devices, then server form, then enterprise data center module. Okay, and in the module of enterprise edge, the e-commerce, internet connectivity, remote access, VPN, WAN and MAN and site-to-site modules. Fine. Static addresses are required for systems such as server or network devices in which IP address must be known all time for connectivity, general access or management. So here we can see that dynamic addresses are at building access level because the system are typically greater than 30. In building distribution, only very few systems are there. Therefore, static routing is preferred. Static IP addresses are preferred. Server form also consists of very small number of servers. To access these server, we must have static IP address. Okay. Remote access or VPN, it uses static or dynamic. Enterprise data center, it uses static. Enterprise teleworker uses dynamic. WAN man site to site uses static. Okay. And static is used by e-commerce module, internet connectivity module because only single systems are there. And enterprise branch uses dynamic IP address. Clear? Using DSCP to assign IP address. DSCP is used to provide dynamic IP address allocation to host. DSCP uses client-server model. The DSCP server can be Windows Server, a Unix-based server, or Cisco IOS device. Cisco IOS device can also be DSCP relay agent and DSCP client. In this figure, we can see different steps that occur when DSCP client requests an IP address from DSCP server. So initially we start with step 1. Step 1 is the host sends DSCP discover broadcast message to locate a DSCP server. Okay, so this is our step 1. What we need to send, this is DHCP discover. This is the message. Okay, then a DHCP server offers configuration parameters such as IP address, a MAC address, a domain name, a default gateway, and a lease for the IP address to the client in DHCP offer. So it will send the DHCP offer. This is our second step. In third step, the client returns a formal request for the offered IP address. Step 3, the client returns a formal request for the offered IP address to the DHCP server in a DHCP request. Okay, DHCP request. This is third step. Broadcast message. And finally, the DHCP server confirms that IP address has been allocated to the client by returning DHCP acknowledgement. DHCP acknowledgement unicast message to the client. So this is how the 4-step process is done for assignment of IP address using DHCP. Then come to DHCP relay. A DHCP relay agent is required to forward DHCP message between client and server. Okay, when they are on different broadcast domain IP subnets. For example, DHCP relay agent receives a DHCP discover message which is sent as a broadcast and forward as DHCP server on another subnet. Fine. A DSCP supports three possible address allocation mechanism: manual, dynamic, and automatic. DSCP. Okay, this is not static or dynamic IP address. DSCP, Dynamic Host Configuration Protocol, supports three possible address allocation mechanism. It is manual, automatic, and dynamic. Remember, the network administrator assigns an IP address to a specific MAC address. DSCP is used to dispatch the assigned address to the host. So this is manual. It is based on MAC per MAC. Okay, because MAC is the unique IP address, and for MAC unique physical address, and for MAC IP address is assigned, which is also static. Then automatic, DSCP permanently assigns IP address to the host. So this is automatic. And then dynamic, DSCP assigns IP address to host for limited time called lease. Okay. Or until the host explicitly release the address. This mechanism supports automatic address reuse when the host to which the address has been assigned no longer needs the address. So this is the scenario where we can use DSCP uh, addressing location. Fine. Now come to name resolution. Names are used to identify different hosts, the resource on the network to provide user-friendly location interaction with the computer. A name is much easier to remember than IP address. This here, the purpose of name resolution provides information about different available name resolution strategies and discussion domain name server and name resolution. Hosts. Hosts are the computer, server, printers, and so forth identify themselves to each other using various name schemes. Each computer on the network can be assigned name to provide easier communication between devices and among users. Because the IP network layer protocol uses IP addresses to transport datagram, a name that is used to identify hosts must be mapped to resolve into IP addresses, that is known as name resolution. To select the desired name resolution method, there are some questions. How many hosts require the name resolution? Are applications that depend on the name resolution present? Is the network isolated or connected to the internet? If the network is isolated, how frequently are the hosts added and how frequently do name changes? So a simple name is localhost. Localhost is default name and its default IP address is 127.0.0.1. Okay, so this is localhost. And because everybody knows the IP number 127.0.0.1 is loopback address, so there is no problem. But localhost, if we type ping localhost, this also works well. And localhost remembers, you are very easy to remember this. Suppose one address is 133.33.13.31, then there may be chances of confusion. Okay, he where that one is coming or where this three is coming, so there may be chances of confusion. To avoid these confusion, we need name resolution, naming strategy. Okay, so static versus dynamic name resolution, let us discuss. The process of resolving hostname to an IP address can be either static or dynamic. First is static. With static name IP address resolution, both administrative overhead and the configuration are very similar to those of static address assignment strategy. The network administrator manually defines name to IP address resolution by entering the name and IP address pairs into the local database, that is HOSTS file. These are the important files. So using either a graphical or text interface. Most of the time in Linux interface, we use text interfaces using gedit, sudo gedit, then HOSTS. Okay, this file is located somewhere, so we need to give the path. Fine. They must be entered on every host and are prone to error and omissions. Yes, correctly. There may be possibility of errors. Then come to dynamic. Dynamic name to IP address resolution is similar to dynamic address assignment strategy. The administrator has to enter name to IP address resolution only a local DNS server rather than every host. The DNS server then performs name to IP address resolution. Renumbering and renaming are easier with the dynamic name to IP address resolution. Now come to a question, when to use static or dynamic name resolution. So there are some criteria. Number one is the number of hosts. If there are more than 30 and system, dynamic name resolution is preferred. Okay, dynamic if it is greater than 30. And it is the static name is manageable for fewer hosts. Then come to isolated network. If the network is isolated, it does not have any connection to internet and the number of hosts is small, static name resolution must be appropriate. The dynamic method is also possible. The choice is an administrative decision. Then come to internet connectivity. When internet connectivity is available for end user, static name resolution is not an option and dynamic name resolution using DNS is mandatory. Then come to frequent changes and adding of name. When dealing with frequent changes and adding names to a network, dynamic name resolution is also it is recommended, not also. Application depending on name resolution. If application that depends on name resolution are used, dynamic name resolution is recommended. Using DNS for name resolution. So there are some steps. Okay. To resolve symbolic names to actual network address, applications use a resolver or name resolver program, which are usually part of host operating system. An application sends a query to name resolver that resolves a request with either the local database, that is HOSTS file, or the DNS server. When numerous hosts or names must be resolved, IP addresses statically defined resolutions in host files are unlikely to maintain. To ease this process, DNS is used for name resolution. DNS is a client-server mechanism used to access distributed database providing address to name resolution. A DNS server is special software that uses resides on the dedicated hardware. DNS server and are organized in a hierarchical structure. A DNS server can query either DNS servers to retrieve partial resolutions for a certain name. For example, one DNS server could resolve cisco.com and another can resolve www. To enable DNS resolution, the network administrator sets up DNS server, enters information about host name and corresponding IP address, and configures the host to use DNS server for name resolution. A recommended practice to use DNS server is for initial name resolution when there are more than 30 host services or fully qualified domain names, that is FQDN. Okay, FQDN. To resolve IP address, an external DNS server is required to provide access to hosts outside the organization. And FQDN is the complete domain name for specific host on the internet that contains enough information for it to be converted into a specific IP address. The FQDN consists of host name and domain name. Like Cisco.com is FQDN on web, the Cisco web server. The host is www, the domain is Cisco, and the top level domain name is com. So in this figure, what are the different steps? Okay, initially we started step number one. What is the address of cisco.com? A user wants to browse www.cisco.com because the host does not know the site's IP address. It requires DNS server. Second step is The DNS server responds with appropriate IP address for www.cisco.com. And the third step is the host establishes a connection to the appropriate IP address, that is www.cisco.com. It is established. So this is how one can connect with the host. So this is how user application name resolver is there. User application, this is our user application part. Then name resolver resolves the IP address. It resolves the IP address and finally go to the DNS server. DHCP and DNS server location in a network. So in this figure, DHCP and DNS server can be located at multiple places in the network depending on the services they support. For the enterprise campus, okay, here in server form, DHCP is located, okay, and DNS is also, internal DNS is also located, external DNS is located at SP premises, and so many different places are there, like in enterprise branch also DHCP or internal DHCP DNS is located. With this we finish our lecture, which consists of designing an IP address plan, private and public IP address, determining the size of network, planning the IP address hierarchy, method for assigning IP address, name resolution, and DHCP and DNS server location in a network. So we have already seen the DHCP and DNS server location in a network. In next video, we will cover introduction to IP version 6 addresses. So thank you for now. Bye bye. Have a nice day. Have a nice time.